Hi everyone, welcome back. So in this video, I'll be explaining the very basic neural network, that is the perceptron. So perceptron was actually developed in the year 1957. You can see it's a long way back, right? So it was a very simple model, but before explaining what a perceptron is, I'll just recap the logistic regression model, because logistic regression and perceptron is very similar. So let me start. So I hope you can see my screen. So let us start with a logistic regression model. So if you have not watched my logistic regression video, you can simply go to the playlist of machine learning. I guess in the playlist of machine learning, I have already explained a logistic regression in very details. Okay, so if you have not watched it, please watch it. I'll just give a link to the video in the description section. So I'll just recap the logistic regression a bit so for reference. So in logistic regression, what happened? There was a data set D of xi and yi, right? So here, given a xi, our task was to predict the yi hat, meaning given a xi, I had to find what the predicted value of that particular point is, right? So in case of logistic regression, the y hat was found out like this. So sigmoid of w transpose x plus b. So this was how the predicted value of a point in logistic regression. This is pretty much the logistic regression model. The prediction was, right, the prediction formula. Okay, where xi and yi, obviously they belong to dimension d, for example. Okay, and yi is not belonging to w. Just a second. Okay, it's not yi, is actually xi and w. Okay, w is a vector which is of dimension, which belongs to dimension d, right? And yi is a value, like in logistic regression is a classification technique, so it is basically a scalar, right? And b is also a scalar. Done. Now what do you mean by training a logistic regression? Training a logistic regression means finding the optimal w and b. We had to find w and b, the base w and b. That was training a logistic regression model means, right? So what actually we had to find out, yi hat equals to sigmoid. I am writing sigmoid of, what is it? It is, I'll just write it in a detailed way. It is w transpose x plus b, right? So we can write it as, it's nothing but so it is nothing but summation of I equals to 1 to d, given that w is a d-dimensional vector, x is also a d-dimensional vector. So wi xi plus b, right? We can write it like this. Yes, where x is a d-dimensional vector, w is also a d-dimensional vector, right? So this was what we were required to find out, right? How did we train it? We trained it using the model which had the base W's and B, right? This was how you can just go back to the logistic regression video and see the optimization equation, right? Where we have actually found out how to minimize W and B using gradient descent. So now, what is a perceptron? I'll write in a new page with a new color, let's say. Okay. So perceptron is a very simple model which was developed in the year 1957. It was like, just bear with me, xi1, xi2, xi3, let's say we have xid. So it is, x is a d-dimensional vector, okay, and each of these has a edge to something called as a neuron. Let us suppose this is f, okay, and the output to these was nothing but the yi hat. Okay, here what is b? B is nothing but, let us add another edge, let us call it b, and let us put a 1 to the input. So this is nothing but the input layer, and this is nothing but the output layer. So perceptron was a very simple model which simply had two layers, input layer and the output layer, and nothing else. And here these edges were named as W1, W2, W3, let us say WD, and here we can simply name the edge as B so that we can compare it with a logistic regression. Here, what is f? F is called the activation function. When it comes to perceptron, f is nothing but the activation function. So how did you find out yi hat? We could find it like f of, so this is nothing but the sum of products, okay? So xi1 into w1. So see, xi1 w1 plus xi2 w2, okay, and so on up to x, so here I'll give a plus, xid wd, right, plus 1 into b. Okay, so this is how we could find out the yi hat. Okay, so we can write it as f of w transpose x I plus b. It is similar, right? This is nothing but the yi hat. So in case of perceptron, so you see the concept. First understand the concept. Okay, so let us understand this conceptually. So what are these weights? So let us understand it with a table. So let's say I have 4 features. So feature 1, feature 2, feature 3 and feature 4. Okay, and these are nothing but the column, the rows, 1, 2, 3, 4, let's say 5 rows. So what are these? You see this xi1, I means, I signifies row, and this 1 signifies column number. Okay, so here we have d features, d columns. Okay, like in machine learning you have seen that we get a data set, and in the data set we have certain features and certain number of data points, right? So here I denotes the number of rows. So at first this entire vector, let's say this is a vector of size 4, right? And this is also a vector of size 4. Likewise, we have 5 vectors of size 4. So this first vector, let's say this f1, f2, f3, f4, this first vector, just turn it upside down. It will be like this, right? So here, let's say this is height, let's say this is height, this is weight, this is gender, and let's say this is a fourth feature, and let's say this is location. Okay, so let us take an example. Let's say a person is obese or not. Let's say I want to find out. This is a classification problem, right? So here, this is the weight of the person. This is the height of the person. Okay, don't get confused with this weight and the feature weight. This is the weight vector's weight, and this is a feature named weight. I'm taking as an example just. And this is gender, this is location. Now, let us say to find out whether a person is obese or not, this particular feature, let me take a different color. This particular feature, right, F2, this is very important, right? Because the more the weight of a person is, the more tendency for that person to become obese, right? On the other hand, does it have any connection with gender? Very little relevance, right? Very little relevance. So in that case, this particular age corresponding to W2 will be thick, will be very thick in comparison to the other weights. Because this is very important, this feature is very important. So more information from this particular input layer is to be transmitted to the output layer. That is why the W2 should get a very higher value. That means analogically it should be thicker. On the other hand, this gender is almost irrelevant, right? Almost irrelevant. So in that case, this particular W3 will get a very negligible value, and this analogically will be very thin. This particular age will be very thin, right? So this is how you should understand what the weight vector means, okay, and what the ages in the perceptron means. You have to understand it like this. That will be very easily understandable. Here you see the features and rows. In this way you can just relate it. Now let us see, in case of a perceptron, what is this? This is nothing but the activation function. Okay, here you see what is the input to the activation function. This f can be anything, right? In case of this particular perceptron, the activation function will take the input as the sum of the products. Yes, so xi1 into w1 plus xi2 into w2, right? This particular thing, sum of products, this sum of products is fed as input to the function, to the activation function here. Okay, this will be applicable for any kind of neural network. In any neural network, here whatever the function is, whatever the activation function we use, always the input to the activation function will have sum of products from the previous layer. This is the previous layer. So from the previous layer, we'll simply multiply the inputs with the corresponding weights and then add it up. That's it. So in case of Perceptron, which was built in 1957, this particular f is nothing but a thresholding function, a very simple thresholding function. That means W transpose xi plus b, if that value is greater than 0, output is 1. Otherwise 0. That means it is simply a linear classifier. Okay, so here you can see this f is nothing but a simple thresholding function. If this particular value in Perceptron, if this particular function is greater than 1, if it is greater than 0, the output is 1. The class is 1. If it is less than equal to 0, then it is class is 0. It is as simple as that for Perceptron. Because you have to see, Perceptron was built in the year 1957, way old, right? Now, what if this particular function is changed to the sigmoid function? What does it mean? This simply means it is logistic regression. If the thresholding, if this thresholding function, this activation function f is sigmoid, if we replace it with sigmoid, it is logistic regression. If we replace it with simple thresholding function, then it is perceptron. Now you understand the relation between perceptron and the logistic regression. It is very similar. Just change the activation function. Okay, so that is how you get logistic regression. Okay, and you know already the sigmoid function will give you output in the range 0 to 1, and that means you can use it at probabilities, right? So you can just watch the logistic regression video for more details. I have derived the entire logistic regression with various scenarios with examples, and the optimization equation is also present, also explained in that video. And if you have any doubts regarding any concept here of logistic regression, you can go back to my logistic regression video. I'll just pin it up in the description section. On the other hand, if you have any confusion with the perceptrons concept, which is new in this video, then please feel free to comment in the comment section. Okay, I'll try to reply. Thank you for watching. See you in the next video. Bye.